this a quick tip top here on Graham's law of diffusion. I've received a lot of messages. Musjaro, I don't understand Graham's law. Hold it there. Musjaro is with you. So quickly, we want to look at Graham's law of what? Diffusion. Now, talking about diffusion, first off, we need to understand the phenomenon of diffusion. So we get to have a good understanding of the law. Then we need to have get some formulas rather for us to trash some basic questions. Of course, I got some weapons here that some persons have difficulty in solving. So very quickly, let's move on. Now, if I have a container or I have gases, I spray gases. For example, I have gas A, I have gas B, I have gas C, and I have gas D. Now, these gases are moving. Of course, they move randomly, definitely. Now, these gases are moving because the gases are well concentrated in this particular area, and gases move randomly. There is high tendency, of course, that the gases will move from the area of higher concentration to the area of what? Low concentration. So the movement of gases from high concentration to that of lower concentration, that's what's regarded as what? Diffusion. Now, for instance, I'm having a sport meat, and of course, it brings out some pungent and very corrosive odor. Now, as you move towards the area of the meat, what happens is that you get to perceive that gas, the smell very well, because of the area of concentration is very high there in that particular area. Now, there's a high tendency that those gases or the smell of that gas will move from there to areas that have lower concentration. Though it's more concentrated, they will perceive it more here. That's what's happening here. Now, gases tends to move from area of high concentration to that of low concentration. That is diffusion. Now, there's a problem. Now, diffusion and effusion are almost the same, but not the same in a way. What do I mean? Now, if I have a container and it contains and it have gases, now when a gas moves through an orifice like a pinhole, so to say, now the gases are forcing themselves to move through. It's still moving from area of high concentration to low concentration. But what's the difference? The difference here is that the gases are moving through an orifice or hole. Therefore, that process is called what? Effusion. So I can actually say Graham's law of diffusion, or I can actually say Graham's law of what? Effusion. Now, what does this law state? Quickly, let's go to the mainstay of today's class. Now, what does this law state? Now, the law actually states that the rate of diffusion of a gas is inversely proportional to the square root of its what? Molecular mass. Now, inversely proportional to the square root of its molecular mass. Now, what does that mean? It means that because of this inverse proportionality, that is not direct proportionality, it simply means that as the molecular mass of a particular gas increase, the rate of diffusion reduces. Now, this from here, I can get my formula, of course, to represent Graham's law of diffusion, which is R1. So the basic formula for Graham's law of diffusion, R1 over R2. What does this R stand for? Rate of diffusion of gas 1. No, in a mixture of gas, I'm having two gases. So the rate of diffusion of gas 1 over rate of diffusion of gas 2 is equal to square root of molecular mass of gas 2. Be very careful, don't be a fool. Over square root of molecular mass of what? Gas 1. Now, this formula is the basic formula to solve what? Graham's law. Now, but we have to be very, very careful. Very, very careful. Now, remember, like I said just now, that this formula actually says that as the molecular mass increases, the rate of diffusion decreases. Now, what do I mean? If I have gas, hydrogen gas, I have oxygen gas, and of course, I have ammonia gas, which of them is likely to have the highest rate of diffusion? I can actually determine that based on their molecular form, or the molecular mass rather. Now, remember, hydrogen is the lightest gas, yeah? So obviously you should be able to know that if we have the highest rate of diffusion, we want to diffuse first, or we diffuse the fastest if you like. Now, hydrogen is 1, but the molecular mass 2. Now this is oxygen, 16 times 2, that will give me what? 32. Now nitrogen is 14. Hydrogen is 1 times 3. That is what? 3 plus 7 plus 14. That will give me 17. Now, if you look at it, if you good look at these gases, the one that will diffuse first is hydrogen, followed by ammonia. Then the least is what? Oxygen. So the rate of diffusion is actually affected by, or actually determined rather, by the molecular mass. But there's one thing I want to bring out very quickly, that the solubility of a gas also affects the rate of diffusion of a gas. Therefore, what is the statement concerning or regarding the solubility of a gas? The more soluble a gas is, the lower the rate of diffusion. I'll take that again. The more soluble a gas is, the lower the rate of diffusion. So be very careful to put that down, that the solubility of a gas is actually affected, or usually affects the rate of diffusion of the gas. Now, quickly, this is the basic formula, but we should also take note again as we begin to solve, we'll start to solve, that the rate of a gas, that rate is equals to volume over time. Now, if rate is taken as volume over time, very sorry about my handwriting, but you have to focus and look at it very well. Now, if rate, that means I can say R is equal to V over what? Over T. Now, if this is my rate, but remember, my basic formula is R1 over R2 is equals to square root M2 over square root M1. Now, I might want to, if I decide to substitute this R or this V over T as R here, now this formula we have to change. We have a different formula. Now, look at it now. So if I want to do that very quickly, pardon me, that means if this is my basic formula, R1 over R2 is equals to square root M2 over square root M1. Therefore, what should I do? In place of arrow, I'll put V over T. In place of R1, V over T. In place of R2, V over T. So quickly, I will have something like V1, because I'm talking about R1 over C1 over V2 over C2 is equals to square root, of course, M2 over square root of M1. Now, if I have looked at it this way, if I substitute this as a mathematician, very fast, you have to know this is simple mathematics. Now, if I take this up, then I will have this final formula. It becomes what? V1 T2 over V2 T1 is equals to square root M2 over square root M1. Now, what am I trying to bring out here? Now, very quickly, this is the basic formula, so number one. But remember that rate is V over T. So I substituted V over T into R1. That's how I got this expression here. Then I have this. So equation number 2. So sometimes you are being given volume to calculate for the time it will take the particular gas to diffuse and all that. So you got to apply this formula. Now, be very careful with this formula while using it. But there's one other thing I want to bring out again. When the volume of the two gases are equal, of course, it can cancel out. When the two volume, say at equal volume, for example, or when the condition remain the same, so I can have T2 over T1 is equals to square root M2 over square root M1. Now, this is when the volume are equal, or the two gases are equal. So I can actually take this as what? As equation 3. So when you are looking at Graham's law of diffusion, there are 3 basic equations that you should consider. 1, 2, 3. Now let's begin to look at some questions that we can come across when it comes to Graham's law of diffusion. So very quickly, I have to take this off to bring out some basic questions when it comes to Graham's law of diffusion. Now, I have a question here with me that was sent to me by a student saying that he has difficulty in solving it. So I say, hold it. Now let's do this. Let me bring it here so that we can be able to trash it. Let me show you. Now the question says that I'm going to bring it up, pardon me, 100 cm cube of methane. You know, methane, the gas is marsh gas of methane diffuses through a porous plug in 30 seconds. Now, that is the time it took this gas to diffuse. Then I said, how long will it take? How long will it take 200 cm cube of oxygen, now that is the second gas, to diffuse? Now look at it. The question is straightforward and it's very easy. Now, if you check out the two formulas that we gave, basic formulas, the first one that we brought out was that solution. Now, the first one that we brought out was that is R1 over R2 is equals to square root of M2 over square root of what? M1. Now, I cannot use this formula for this in the sense we're giving volume and we're giving time. We're giving volume and we ask for how long? Time. Now, the formula I will have to use is the second formula that we brought out. And what's that formula? V1 T2 over, please don't be a fool, this T doesn't stand for temperature, it stands for time. Now, over T2, or V1 T2 over V2 T1 is equals to square root of what? M2 over square root of what? M1. Now, I will have to summarize some certain things here very quickly. If you notice that the first gas was methane, and of course it has a volume of 100, so I'll bring it out. 100 times, now this is the time it takes the second gas to diffuse. That's what we're looking for. How long will it take 200 cm cube of oxygen? This is the second gas. This is how long, meaning time. So I'm looking for T2 over, now the volume of the second gas is 200 times my T1, the time it takes me is 30 seconds, which is equal to, now my N2 is the molecular mass of the second gas, and this time around is oxygen what? Gas. Now remember, this oxygen gas, sorry I didn't state it out here, this oxygen gas is all generated by what? By O2. Now oxygen has a molar mass of what? Atomic mass of 16. So 16 times 2, that will give me 32. So square root of 32 over square root of, why am I putting 32 here, please? That is the molecular mass of the second gas, which is oxygen gas. Square root of what? Of methane is the second gas, I mean the first gas rather. So 12, the atomic mass of what? Carbon, and hydrogen, which is 1 times 4, that will give me what? 16. So if you get to this place automatically, you definitely know the solvings for this. Of course, this is a mathematical problem. 100, 1, this is 2. So I will now be having, so my expression now from here now will now be what? T2 over 2 times 30, 60 is equals to square root of 32 over square root of what? Of 16. So this, you can punch this straight into your calculator and you make T2 the subject of the formula, so you can have what? Your answer. So quickly, so you see the logic behind this. The logic of these classes is quick one to explain what Gram's law means, and of course a formula when you have questions like this to solve. So there are many questions that we're going to bring out very quickly as the class goes on. Do well to subscribe and do well to follow Musjaro. Thank you for watching. Thank you very much.